So we have three presenters coming up that are representatives from networks that are funded by the same government organization that funds MICA. It's called ISED, through something called the Strategic Innovation Fund. So Canada has, I think it's 9 of these networks, there may be more, but they're all in different sectors of the industry. We're the only mining-specific one, and the 3 that are going to be presenting here represent those other industries. But why are they here? The reason why they're here is we recognize that within these networks across Canada, there's innovations that are sort of coming out from these networks. Some of those innovations are actually mining related, but we need to make the connection. And then also, some of the education and training that we offer to our different SMEs or different ecosystem partners, those same trainings are complementary. So in other words, we want to leverage the investment that government is making in other parts of the industry so that we can get more bang for the buck, if you want to call it that. So that whole cross-industry, cross-pollination piece is what we really want to see happening as we bring these networks together. So the first network I'm going to bring up is Fabric, which is Canada's semiconductor ecosystem. And I'm going to ask Gordon Harling to come up and do his presentation. Gordon, where are you? There you are. Okay, you're in the back. Come on up.
So I'm going to go through this like a rocket ship. I'll start off very quickly, and you can have the slides after, please. So Fabric is actually a project under CMC Microsystems. We're a 40-year-old we're a 40-year-old startup. We've been supporting microelectronics, photonics, microelectromechanical sensors, IoT devices, which includes AI. And as of about 4 years ago, we started a quantum technologies group. So we have technical personnel internally who can help you with any of these, with any projects that are involved in this. Really, we're a broker, and so we work to provide you with tools and technologies. And so we are pan-Canadian. In fact, we offer our services in 22 countries around the world, but in Canada we have, oh good, I can see down here. We have over 1,400 connected professors. We have about 700 research groups that we provide with tools, and every year about 10,000 students and researchers use our stuff. Typically about 800 grads leave the programs and go directly to Canadian industry. Another 400 or so either continue studies or go to research institutions, and then another 400 go to their home countries. I'd like to change that, but anyway, some people do that. And every year we have between 15 and 20 new startups. And 2022, 23, it was a bit of a slow year, probably post-COVID, and we only saw 12. And so we offer 3 different types of services: CAD, computer-aided design services. So we negotiate with 30 major vendors of design software, and then we offer that to academics, heavily subsidized, thanks to Fabric, across Canada. And fabrication, so when you've designed a chip, a photonics device, or a MEMS sensor, we can actually fabricate it for you. And what we do is we cluster 10 or 20 designs together. We make the purchase, and then we split the bill among them. So it's a very cheap way to get prototypes done. And under lab, we actually finance R&D to develop new platforms, not a chip that's good for any one purpose, but that many people can use as a demonstrator or as a starting point for their own design. And then they can come to us for CAD and fab. So we have a quantum group as well, and I'll talk a bit about that. So why Fabric? Well, never waste a good crisis. There was a semiconductor crisis. Everyone else is investing like crazy. And so what we wanted to do is find out what are Canada's strengths and how do we leverage those. So what we did is we looked around Canada and we found that there are a number of different fabrication facilities, but when you go to them, you pay millions of dollars to develop a process to build your chip. And then that's your process and no one else can use it. So what we said to the government is, if we had the money to do this, we would develop a process to make, say, a vibration detection device that could be used on electric machinery to determine when the machinery is going bad and tell you when you need to fix it before it breaks. We could use it to do compound semiconductors, high voltage switches, so that you can make more efficient battery chargers or more efficient electric motors, that sort of thing. And so we identified these processes, and then they asked us, how are you going to commercialize all that stuff? And we said, well, IoT. So IoT, the beauty of it is it's vast. It's everyone from a watch to a space shuttle, anything that's connected. And so we said that we would commercialize through IoT challenges and have people develop products in Canada. We are agnostic as far as the application area goes. We provide the tools. You use them to build whatever you want to build. So mining, of course, is touched here by clean tech, energy, digital technologies, electric vehicles, future natural resources. It spans many of those sort of concentration areas. Oh, there we are. I hate animated slides. So we chose 4 technologies where there are factories in Canada: photonics, compound semiconductors. There's a Canadian Photonic Fabrication Center in Ottawa that does many lasers for a lot of global clients. Microelectromechanical systems, so pressure sensors, accelerometers, vibration detectors, all built in either Bromont, Quebec, or Edmonton by Teledyne. And it's the world's largest open foundry that takes in other people's designs. And then quantum technologies. So there are 2 expansions going on, one to the University of Sherbrooke's 3IT lab and the other to the C2MI in Bromont to build superconducting quantum devices. So we've been running for about 4 years now a design course to allow you to do your own superconducting quantum devices. And on the IoT side, it's everything. It's really open. So we opened a 2-week window for expressions of interest, and we received 138 expressions, half of them for manufacturing processes in these arcane technologies, and half of them for IoT product development. And the total value was $235 million, which is more than our entire 5-year budget. So I immediately sent an email to ISED saying, we've spent the money, can we have more? So we're working our way through all these proposals, and we hope to be making announcements in January. And we'll do 2 or 3 calls for proposals every year and then run them through the system. So we also provide support in terms of, we call it something the innovation platform. So it's the access to software design tools, prototype fabrication. We do a lot of training, upskilling, and we have a quantum ready program so people can try out quantum coding very inexpensively. So our quantum group actually did some coding for a company in Alberta to look at tailing reservoirs, the dam on a tailing reservoir, and they simulated it in a quantum computer to actually determine its potential weak points. And then as we go and develop these programs, we always ask someone to leave behind some part of the design so that others can use it as a starting point. Not the whole product, but a decent usable piece. And so we have the Fabric community, if you'd like to join. You can actually see what IP has been developed and what's available for you to download and use and adapt. So lots of words there. I don't like slides with lots of words, but these 4 different technologies, of course, can all be applied to IoT devices, and we'd be happy to have a discussion with you about how we can solve problems. Clearly, we do have AI support as well. And the mining market is expected to grow quite rapidly. And of course, semiconductors are going to be all over it. And all of the automation stuff we talk about, all of the autonomous vehicles, and all of this condition-based maintenance for equipment is all part of that. So we have an electrochemical sensor that could be functionalized to detect different things. So it could be used for health monitoring of employees as they wander around. If they're in an environment with noxious gases or whatever, you can see what their dose was for the day. We can measure gases and wastewaters using that electrochemical sensor. We have condition-based maintenance. We have some solutions for that using an IoT device that sits on a motor and determines when it's squeaking too much. Photonics, so if you're doing communications in a mine or somewhere where there may be explosive gases, there's no sparks in photonics. So that makes it a lot safer. And you can also use fibers to sense, and you can actually put sensors without any electronics whatsoever at various points in a mine. And you can do strain sensing, so you can determine if the walls are moving, or if the walls are moving, or if things are under pressure, and so on. So really useful stuff. And so we do a photonics toolkit chip, which can allow you to run a fiber down a mine and then actually measure the output using a photonics device. And one of our spin-off companies from a university actually made a quantum sensor. It's based on a piece of diamond with a nitrogen vacancy in it, and it's extremely sensitive. And so it can detect variations in the gravitational field. So if you fly a plane over the forest, you can determine if there are big lumps of more dense material down there. And this can be used to find kimberlites or diamonds. You can have the slides. If you like pictures, that's good. So yeah, so we're developing the ecosystem. We have a Canadian symposium which just happened last month, and so we do more and more partnering, and we'll be having more and more events as time goes on. So feel free to check out our website, and it's fabricinnovation.ca if you'd like to find out more about it. And there's lots of stuff there, and I'm easy to reach as well. Any questions? No? Yeah, we're actually pan-Canadian. So our head office is officially Montreal, but we have people from Edmonton to Quebec City. We're going to be hiring some in Vancouver and some in Halifax soon. So we're about 63 people right now. We're growing to 80, but we're all across Canada. Most of our offices are donated by universities, to be honest. Cheap. We're cheap. My guilty secret is we have this funding to help Canada, but in the background, we're working in many, many other countries. So we created a US subsidiary and we're going after CHIPS Act funding. So we take the same CAD that we offer here, we charge them full cost recovery. We pay our people with that, and we also have about 60 universities in the U.S. using our fabrication services. We're going into Costa Rica, Saudi Arabia, Brazil. So we have lots and lots of activities outside of Canada, and working with the UK as well. Yeah. Oh, perfect. Je vous donne ma carte. That's it. Great.